Hello students, welcome to my channel Math Magic. Today we will discuss about probability from class 12, chapter probability from class 12. And listen everyone to better understand in probability, share more and more your friends and see more and more times. Okay, so let's start today. Conditional probability. Probability already we discussed in my previous video. So today in class 11, the chapter probability, first is conditional probability. Okay, so first of all, what is conditional probability? First of all, what is conditional probability? See, let A and B, okay, let A and B are two events associated with a random experiment, then the probability of occurrence of the event A under the condition that B has already occurred and probability of B not equal to 0, okay, is called the conditional probability and is denoted by, conditional probability is denoted by P A stroke B or A by B. Okay, I repeat again, what is conditional probability? Let A and B are two events associated with a random experiment, then the probability of occurrence the event A under the condition event B that has already occurred. B has already occurred. Okay, and PB, that means probability of event B not equal to 0, that means is called the conditional probability and denoted by P A stroke B or A by B. So in short we can say that conditional probability A and stroke B is probability of occurrence event A given that event B has already occurred. That is the shortest form. So what is conditional probability? P A stroke B, number of outcomes favorable to, see, number of outcomes favorable to event favorable to A intersection B divided by number of outcomes favorable to A intersection B divided by number of outcomes favorable to B. Number of outcomes favorable to event B. Okay, so we can write probability of A intersection B divided by probability of B. That is the main formula of conditional probability. Okay, so conditional probability P A stroke B equal to number of outcomes favorable to A intersection B divided by number of outcomes favorable to B, and must P probability of event B not equal to 0. Probability of event B not equal to 0. Clear? So this is the main formula of conditional probability. Okay, so using this formula we do some sums or give some examples, so better understand, see carefully. So first example, see here, first example is listen the question first. Question number 1, 10% of the bulb purchased in a factory, 10% of the bulb produced in a factory are the red color and 2% are red and defective. Okay, see, example number 1, 10% of the bulb in a factory are red color, and 2% of the bulb are red and defective. Okay, red and defective. Okay, now the question is 10%, 2% of the bulb red and defective. Now the question is, if one bulb is picked up at random, determine the probability of its being defective if it is red. That means find the probability of defective bulb and it is red. Okay, so see carefully, A is the event that is red bulb. Let A is the event that is red bulb. B is the event that is defective bulb. Okay, A is late, A is the event that is red bulb, B is the event that is defective bulb. Okay, so probability of event A equal to 10% red color, that means 10 divided by 100. Probability of event A intersection B, that means probability of A intersection B, that means defective red and defective, that is 2%, that is 2 divided by 100. Okay, now the question is, one bulb is picked, determining the probability it's being defective and it is red. So defective and it is red. Okay, so therefore probability of B stroke A, required to find probability of B stroke A. Okay, so probability of A intersection B divided by probability of event A. Okay, so A intersection B, already we get A intersection B equal to 2 by 100, and probability of A, that is 10 by 100. Okay, after calculation we get 2 divided by 10 or 1 by 5. This is the answer of conditional probability. Okay, I hope all of you clear. Next, come to the second example. Okay, see carefully. Next, come to the second example. Example 2. See carefully. Example 2. The question is, in a school 70% students passed in physics. In a school 70% student passed in physics. Okay, PHY means physics, and 75% student passed in mathematics. 75% students passed in mathematics. Okay, now the question is, 75% student passed in mathematics and 10% student fail in both. 10% students fail in both subject. Fail in both, that means fail in both subject. Okay, now the question is, one student is chosen at random. One student is chosen at random. What is the probability that he passed in physics, given that passed in mathematics? Find the probability. If we pick a student, find the probability he passed in physics and given that he passed in mathematics. That means passed in mathematics, that event already given. Okay, now see, suppose event A late, event A passed in physics. Okay, now event B, that means passed in mathematics. Passed in mathematics. Event A, that is passed in physics. Event B, passed in mathematics. Okay, now see, probability of event A, that is passed in physics, that is 70%, that means 70 divided by 100. Now probability of event B, that means passed in mathematics, that is 75%, that is 75 divided by 100. Okay, now 10% fail in both subjects, that means probability of A conjugate intersection B complement equal to probability of A complement. A is the event passed in physics, B is the event passed in mathematics. Here 10% fail in both, that means complement event. A complement intersection B complement, that is 10%. 10 by 100. Okay, now PA union B equal to 1 minus 10 by 100. Okay, that is 90 divided by 100. 90 divided by 100, probability of A union B, that means passed student, that is 90 divided by 100. Okay, now using the formula of properties of probability, we got the result of PA intersection B, that means passed in both subject, mathematics as well as physics. So PA union B equal to PA plus PB minus PA intersection B. Okay, so PA intersection B equal to PA, probability of A, that means 70 by 100. Then plus PB, probability of B, that is 75 divided by 100 minus PA union B, that is 90 by 100. Okay, now what is the result? 100 is the LCM. So what is the result? 70 plus 75 minus 90. That means 55. 55 divided by 100. Okay, so PA intersection B, that means passed in both subject, that is 55 by 100. Okay, now there the question is, now probability of the question is, find the probability that the past in physics given that past in mathematics. Okay, so past in physics, that means A stroke B, okay, or A by B, because past in mathematics that event already given, already occurred. Okay, that is the condition, that is conditional probability. So A by B, that means PA intersection B divided by PB. Okay, so PA intersection B, that is 55 divided by 100. Okay, now PB equal to past in mathematics, that is 75 by 100. 75 by 100. So after calculation we get 55 divided by 75. So 11 divided by 15. Okay, so the conditional probability, if we pick a student, what is the conditional probability that the past in physics given that past in mathematics, that is PA in A stroke B equal to 11 by 15. This is the answer. Okay, hope all of you understood. Next, come to the third example. Listen carefully. The third question is, listen carefully, the question is, a committee of 4 students selected at random from a group of 8 boys and 4 girls. Okay, 8 boys and 4 girls. A committee of 4 students is to be formed, okay, out of 8 boys and 4 girls. So 8 boys and 4 girls, given that there are at least one girl on the committee, given there is at least one girl on the committee, calculate the probability there are exactly 2 girls on the committee. Calculate the probability exactly 2 girls on the committee. Okay, and the condition is given, already given. That condition is at least one girl including in the committee. Okay, so 4 candidates. Okay, 4 candidates select to form a committee out of 8 boys and 4 girls. Okay, now listen. We take A, at least one girl is chosen. Event A, we take event A, at least one girl is chosen. Okay, event B, let event A, at least one girl is chosen. Event B, exactly 2 girls, exactly 2 girls, are chosen. Okay, exactly 2 girls are chosen. So event A, at least one girl is chosen. Event B, exactly 2 girls are chosen. Okay, now PA complement. That means we choose a event, that means no girl is chosen. So there are 8 boys. So 8C4 divided by how many number of committee total, how many total number of committee can be formed out of 8 boys and 4 girls, taking 4 at a time. That means 8 plus 4, 12C4. Okay, so that is the event of A complement. That means in this committee there are no girl. Okay, so after calculation we get 70 divided by 495. After calculation we get 70 divided by 495. Okay, after reduction we get 14 divided by 99. 14 divided by 99. Probability of this event, there are no girl in this committee. Okay, now probability of A equal to probability of event A, that means at least one girl, 1 minus 14 divided by 99. Okay, 1 minus 14 divided by 99. So what is the answer? 85 divided by 99. 85 divided by 99. Okay, so we get PA So now find P A intersection B. Okay, A intersection B. That means A intersection B equal to two boys and two girls. Okay, find probability of two boys, or choose two boys and two girls. Okay, see 8C2 from 8 boys take 2 boys, 8C2 into from 4 girls choose 2 girls, 4C2 divided by total outcomes is 12C4. Okay, so after calculation we get 56 divided by 165. 56 divided by 165. Got it? So we get PA intersection B. So now next question is, the question is find the probability that there are exactly two girls in the committee. Okay, so PB by A. So probability of B by A or B stroke A, that is PA intersection B divided by PA. Okay, now just put the value. PA intersection B, that is 56 divided by 165 whole divided by PA, probability of event A. Probability of event A 85 by 99, 85 divided by 99. Okay, now calculate and reduce. After calculation we get 168 divided by 425. 168 divided by 425. Okay, that is the answer. So hope all of you clear. Thank you, students.